Hello everyone. I hope all of you are fine. I'm Mohammad Shovon and today I'm here for my project to IBM Coursera Advanced Data Science Capstone project. And it was about COVID-19 world case analysis. As I selected COVID-19 world case analysis in my project, I will show you and I will explain you how to analyze the data and visualize the data with machine learning and Python. So everyone, let's have a look on my project. So everyone, you have already known about this that I am selecting COVID-19 data, that means world cases data, and it is my project COVID-19 data analysis and visualization with machine learning and Python. And you have already uh, known that I am Mohammad Shovon in my introduction. So let's start here. Our today's objectives. After watching this video, you will be able to know about my project, describe the project, get idea about different plots, see the visualization of raw data, have knowledge about data science. The topics we cover in this presentation, these are use case, data set, data quality assessment, data exploration, data visualization, feature engineering, selection and justification of model performance indicator, machine learning algorithm and deep learning algorithm, model performance between different feature engineering and model compared and documented. So here is the use case. In this project, I am going to work with COVID-19 data because the situation we are going through. We are the victims nowadays. For the purpose of building a good model, I will analyze this and visualize for you better understanding. And I am importing the data set from this link. It is given here and it is from GitHub, and in GitHub there was a link. It was about Amazon News, that means Amazon S3 Explorer. So from this I have selected my data and it was in CSV form. Now you can see here I have read this data, and in the data frame here is the head of this data, and you can see there are almost 60 columns and 1,08,461 rows. Here are the columns you can see here. Then the topic data quality assessment. Here we have to deal with missing values, and the first of all I have to identify the missing values. So in the function is null, we can select this, we can show this here. Then the function is null and any, we can see that in how much columns there are some null values. Okay, so here true is about it contains null value. Okay, so here we can see how much null values are there in the columns. So after isNa function, we can also call the sum function to count this. Here you can see. Then we can count the missing values in another form. You can see here. Now we will see the correct data format here. So if we call the data types from data frame, then we can see here it. Then I have done data normalization in my project, and here we can see then there are the feature engineering, that means they deal with missing value. In this process we have dealt with the missing values. That means we have to follow different ways, but I have selecting one way, that is I am covering the mean, then the drop the values of NA and replace with the mean values. Now let's see some visualization. So here we can see COVID-19 case in India. Here the data frame, that means that data frames of the Indian case. Here this is the line graphs, and it was about the date, per date, total cases. Then the another one, it was about last 5 days, total case in last 5 days. Here the total test per day. And now I am explaining about the Bangladesh COVID-19 case analysis. Here we can see the data, the head data, the tail functions data. Here it is the it's a graph for total case per days, and it is also the graph for total case in last 5 days. And here it was about total test per days, and this graph is about total tested in last 5 days. Now comparison between the data of Bangladesh, Pakistan and Australia. We can see in this plot, we can see here it is a bar plot, and we can see from the beginning date of COVID-19 to till last date, we can see the COVID cases in graphs of Australia, Bangladesh and Pakistan. That means in 3 locations we can see the visualization of cases. Now we will see the world case for top 15 countries. Okay, so here we can see the maximum case. Okay, as we selected from index 1 to 15, so there are 14 countries bar plot. You can see here. So it is not only the countries, it is also contain the continent. So you can see the upper, it is Asia continent, that means the most of the cases here. In second, Europe continent, and the third, North America, fourth, South America, and the fifth, it is United States. And this is not the continent, it is the country. Now you can see the histograms of total overall cases, so that means world cases, and there are 60 columns, but in histograms there are only 55 because of some there was some object data, that's why. Now you can see the data exploration here. Now the correlation and rate plot. You can see in this result output of correlation, it was so low, it was 0.4, and the another one, it is new test versus new death, the correlations, it was almost 1, and the new cases and the new deaths, this correlation is good, that means it is relatively close to 1, that means 1, and another is 0.9, and this is the overall correlations of the data. Now you can see the box plot. Okay, so I'm using it with Shovon's library. The box plots of some continent and new cases. The first one, the second one is location versus new cases. And here you can see the box plots of test units and the new cases. Now we will describe the total data, and here we find the count, mean, standard deviation, minimum 25%, 50%, 75%, and maximum data. And while we specify it with object, then there are only 5 columns here. You can see. Now the value count for the continent column. You can see here there are 6 continents, and the total values are distributed between this continents. And now there are the groupings data, basics of groupings. We can see here we are grouping with continents with new cases, then continents, new cases, and tests per unit. And now you can see a color bar, and it was about the grouped pivot we have done before while grouping. Now we will see some machine learning, deep learning algorithms. The first one, it is linear regression. So after doing this, here this is the graph of total case in India. It was about regular date versus the total case. You can see the graph here, and this is the residual plot, and it was also about the date versus total cases, and the plotting actual versus fitted values per day case. Here you can see the difference that we have the predicted models and the actual values. And you can see here the mean square error for the linear regressions. We are importing mean square error. The second one, that is R square score, and it is 0.854928. So we can see it is so close to the accuracy. Now the another algorithm, it is naive. We can see for this data I have used multinomial naive. You can see here the predicted values, then the plotting with respect to multinomial naive, here the line chart, and this is the plots for naive in regular date per total cases per date in India. And this one, the model performance indicator, here we can see the F1 score. It is so poor score here. So we can see that the model performance between different feature and engineering. So after seeing the F1 score, we can say that the linear regression here, it is fitted better than naive Bayes. Okay, as we have done with multinomial naive Bayes. So linear regression can provide the best result. And we have the feature engineering we have used here. It is color bar, then F1 score, the correlations, dealing with missing values, etc. So you can see the compare between linear regressions and naive Bayes. Model compared and documented here. The result of linear regression score, it is 0.85492870. It is
it is close to 1, and the naive score, it was 0.041666. So we can say that the linear regressions provide us the best result for this specific data. So thank you everyone. I hope you have now got a clear idea about the
Welcome back. I hope you have enjoyed the video and now you are clear about COVID-19 world case analysis. Okay, and you have already seen about different kinds of data analysis and visualization in my project. So that's all for today. I hope you have enjoyed and thank you everyone. Goodbye.